Next, we're going to work with transforming logs. So we just went over like the introduction to logs. Log base 10x. So we're going to focus on is specifically log base 10. This is an important one. We need to remember those major points because they're going to help us when transforming this. So we're going to try to think of those key points so we can get general sketches. We knew some of the key points of this, okay, for x and y. And if you can't remember them, we can, on the side, I'm just going to write 10 to the power of x.
Yeah.
So we know that we can just invert these key points. So it's really easy. At -1, we know this is a tenth. At 0, we know it's 1. And at 1, we know this is 10, right? So let's invert these to make our log base 10. Well, that means at 1/10 x, we're at -1. At 1, we're 0. And at 10, we're 1. Okay? So let's actually draw the log function here in blue. At 1/10, we're at -1. So something like that. At 1, we're at 0. And at 10, we're at 1. So do you see at the extreme how fast this thing takes off from here to here? It really builds up very quickly. And then here it's extremely close to the y-axis without touching. So this is our f at x for log base 10. Okay. So now what we're going to do is talk about the transformations to this. Now we've talked about transformations many times before, and we're just going to add them back in. So our a value does stretches and compressions vertically, right? So we're going to say S and C, stretches and compressions vertically. We know that that's what A does. A log base 10. We have K. We'll talk about those all later. X, you guys use D?
Mm-hmm.
Okay. And then plus C, correct?
Mm-hmm.
Excellent. Okay. K, we know does horizontal stretches and compressions, and technically flips, just like A flips it also on the XY axis. D, we know moves left and right, just inverts it, right? If it's a negative value, if the whole value is negative, we go to the right. If the whole value is positive, we go to the left. And finally, C does the same idea, up and down, except it's positive is up and negative is down. So let's actually take a log function here and see if we can just transform them a few at a time. Okay, and we'll do it one step at a time. Have they given you any to practice with? Let's look at this one here. So they've given us y is equal to -2 log 10 x minus 4. All right, quickly, what two variables are involved here?
2 and 4.
Okay, and what did they stand for? I'll zoom out a little. What do they stand for in terms of our unknown variables, A, K, C, and D?
A and C.
Okay, so -2 is our A, and 4 is our which?
C.
C?
I mean D.
D. It's inside the brackets, right?
Yeah.
So that's going to represent our D. So let's go about maybe stretching this first. If we're going to stretch this, what's going to happen is we know that our y values are going to essentially be multiplied by our value of -2. Okay? So if our y values are multiplied by -2, let's affect our major y values. These are the two we have. So we'll zoom in again. We'll do this guy in red. So the first transformation will just focus on y equals -2 log base 10. Okay, then we'll actually move it after. So the -2, well, what's going to happen here is our y value here, which is at -1, we're going to multiply that by our -2. So when I multiply that by -2, what do we get?
2.
2. So because a was negative, what has it done to this?
Made it positive.
It's made it positive. In other words, it's going to invert this, right? So now we're at, when x is 1/10, we're at +2. Okay? Our other value of y being, this is 0. Well, what's 0 times -2?
0.
Yeah, so that point's going to stay the exact same. And then this one here, our y value is 1. What's 1 times -2?
-2.
-2, so it's over here. So this one, if you notice, has stretched it. It's made it a little bit elongated. Okay, and I'm going to cut right through there. And it's inverted it. That's what our A has done to this. Okay, so this has become inverted, so flipped on the x-axis, and it's been elongated a little bit, about 2 times. The next step we're going to do is we're going to take that, and we're going to y equals -2, so we'll keep the same stretch, log base 10 x minus 4. Well, minus 4, this is our d, and d moves things left and right. And because it's negative 4, which direction are we going to move it?
Right.
Right, so I'm going to take these major points now, this one and this one specifically, and I'm going to move them to the right. So this is going to become, because this is at a tenth, think of it like 1/10 plus 4. So what are we going to be at? What is our new x value going to be?
4/10.
4/10. So we're at 4/10, something like that. Okay, we're at 4/10. And what about our value here, which is at 1? What's that going to be at?
4. I mean, 5.
5. Okay. Now think of this vertical asymptote as being part of the question. Okay, so let's put him in green. Actually, we'll put him in red to start. Because there's a vertical asymptote, when we shift something to the left, think of it like the vertical asymptote is also shifting left and right. So this goes over 1, 2, 3, 4. So our new vertical asymptote, is actually at 4. It's not going to touch 4. Okay? And then when we go to draw the rest of this function, it's going to come up and go there. And then we know it's going to roughly take off. Technically, it needs to go to 14, something like that. Okay? So this is our new function. Our y is equal to negative 2x minus 4. So that would be the first one. And what we'll do, so we've made up another question here. And again, we'll just relate it to our transformations. We have a log 10 k x minus d and plus c. So we have two values here. Which do they represent and what are they?
So k and c. So k would compress it by half.
That's right. You compress it by half.
And then c would just move it up 2.
Yeah, exactly. So we're on log base 10 again. So let's draw this function. We know quickly it's going to be at 1/10 negative 1. It's going to be at 0 and 1, and then 10 and 1, right? So let's do rough sketch of our log base 10. That's the original one. So f at x is equal to log 10 to the x, okay? So let's deal with these transformations. We'll do with the stretch horizontally left and right first. You're right, because it's greater than 2, we know k greater than 2. If you don't remember that stuff, you can just go back to all those other transformation rules. When k is greater than 2, it's going to compress it by a factor of 2. So in other words, think of it like we take our x values, because it affects the x-axis. We take our x values and we're going to divide them by 2. Okay? So our first x value here is 1/10. Right? So 1/10 divided by 2. Do you know what that's going to give you?
Is it a 20th?
Yeah, 1/20th. So another 1/20th, it's even smaller, so it's here. Okay? I know it's very hard, I can't zoom in all that way, but that's what it's supposed to be. That's supposed to be 1/20th. Our next value is at 0. So we take 0 divided by 2, what do we get?
0.
0. That stays. Whenever we're crossing that point, it's going to stay the exact same. And then finally, our last x value is 10. Well, it's 10 divided by 2.
So
5, that's right. So then this effect is going to happen at 5, which then means, well, the next one would be 100. Next easy one to do, and 100 divided by 2 is still going to be 50. So what this has done is it's kind of made it look a little bit wider, I guess you could say, in terms of the way it's going around the original, right?
Yeah.
It's been pulled up a little more. Okay, that's what the effect is. And that would be, this would be a function of just, because we've only done one transformation, log 10 2x. That's strictly the k transformation.
Yeah.
The c transformation does what?
Moves it up 2.
Moves it up 2. So we take these points and we just go up 2, right? So we go up 1, 2. So that's going to be 1/20th and 1. We know that's going to be one coordinate. This guy's 0, right? So he goes up 2. He's going to be at 1 and 2. And this coordinate here, which is at 5 and 1, goes up 2. So it's going to be at 5 and 3. Okay. And again, our horizontal asymptote stays the same. Because there's no inversion, that that vertical asymptote is not changing. So it still is extremely close going down here, and it does take off, and it takes off in this direction in a more gradual method. So this is our f at x is equal to log 10, 2x, and then plus 2. So that would be our final one. So obviously we could do all four together, and it would be the same idea. You just actually have to put all four together, which gets quite messy, but they're the same types of transformation we've done before in transforming quadratics, cubic, any of the other functions, even exponentials. The only difference is, actually specifically exponentials would be a great one to look at, but it's just a new function, so we're working with logs. That's the only real difference.